Hi guys, welcome back. Be sure to subscribe to my channel because that will help me get funding from advertisers, which will help me continue to do videos and make them of better quality. These take time and equipment. Now all I have is my cell phone basically. All right, let's do a problem about, this is like synthetic division. For the function f of x equals x cubed plus 3x squared minus 34x plus 48. A, list all possible rational zeros. B, find all zeros. So this is like a typical homework problem. First note that I'm using printer paper because paper with lines on it, that's for writing English essays. The lines I find get in the way of math work. Also notice I'm doing landscape mode. I like that so I don't have to break up my equations. Portrait mode also works. All right, so for part A is list all possible rational zeros. I think this is a dumb problem because, I mean, obviously what we're getting exercised on is the rational root theorem, but like, I mean, honestly, really mean like list all possible rational zeros. The zeros are the zeros, that's like what they are. What the rational root theorem does is it will narrow down candidates of, if a zero's a rational number, it will narrow down the candidates. But this is just, it's not precise thinking to say something like list all possible rational zeros. Anyway, let's proceed. So I hope you know the rational root theorem. I like you guys to understand everything, but I don't think at your level you can really understand the rational root theorem. You'll just have to memorize it. So the rational root theorem basically tells us that if a rational number is a zero, then it's got to be a factor of 48 divided by a factor of this coefficient here, which is 1. So we need to find the factors of 48. And to do that, I'm using a theorem which says that every positive integer greater than or equal to 2 has one and only way to factor it into prime numbers. That's a fact that it's hard to prove at your level. It would be hard to understand at your level of math, but try, or at least put it on the back burner for something you want to prove when you get more advanced in math. Anyway, so, it'd be good to factor 48 into primes. So 48 equals 12 times 4, which is 4 times 12, which is 2 times 2 times 2 times 2 times 3, which is 2 to the 4th times 3. Now notice what I did here. This is called the canonical way. Canonical just means traditional way to factor a positive integer greater than or equal to 2 into primes. Notice I'm writing the primes in increasing order, and that I'm using exponents to make the notation concise. And another thing that you should understand is any factor of 48 is going to be of this form: 2 to the m times 3 to the n, where m and n are non-negative integers. And to make sure I'm not leaving any, I'll just sort of be sure, I'll do it in a methodic way, just sort of like I'm counting. So we have 2 to the 0 times 3 to the 0. The most that n can be is 1, right? Because you can think of this as 3 to the 1. And the most that m could be is 4. So 2 to the 0, 3 to the 0. 2 to the 0, 3 to the 1. 2 to the 1, 3 to the 0. 2 to the 1, 3 to the 1. 2 to the 2, 3 to the 0. 2 to the 2, 3 to the 1. 2 to the 3, 3 to 0, 2 to the 3, 3 to 1, 2 to the 4, 3 to 0, 2 to the 4, 3 to 1. And we can look at the pattern here. You've got, so 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3. Now, suppose it's like a counting system. So we have 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0, 3, 1, 4, 0, 4, 1. All right, then if we, I guess you might say simplify, we got 1, 3, we've got 2, got 6, got 4. Where did I get that 4? Oh yeah, I see it. And we've got 12, got 8, we got 24, we got 16, and we've got 48. Now to make sure, let's just count. So we've got 5 choices for this exponent, 2 choices for that, so that's a total of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we got our plus or minus signs. So let's make sure we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. For part B, you know, there's like a theorem I want you guys to understand rather than just memorize. So let's try to like prove the theorems that we're going to use for part B. Remember, part B is find all the zeros. I think it's sort of obvious. We're supposed to be just dealing with real numbers, not complex numbers. Okay, so suppose R is a root. That just means a zero. Well, sort of the same thing. Suppose R, I should say zero. Suppose R is a zero of F. Then when we divide x cubed plus 3x squared minus 34x plus 48 by x minus r, there is a remainder of 0. Try to understand that, maybe stop the video. Understanding is more important than memorizing. All right, so let's look at exhibit 1. So we're going to do that division. Now, noting this, if this were a problem, since we're pretending this is a problem assigned by a teacher, like for your homework, we know that it's not going to be too hard, so it's probably going to be one of these small numbers that we're going to guess. It looks like a positive number is not going to work, so let's try something negative. It looks like 1 may be too easy, so let's try a 2. Let's make it negative. Looks like a positive is not going to work. So we've got the synthetic division going on. Actually, it looks like we're trying a 2. Yeah, it looks like we actually are trying a positive number. This would be a 2, right? Because we're dividing by x minus 2. And the way synthetic division works, yeah, so yeah, trying 2. 1, 3, negative 34, 48. Bring down the 1, multiply by 2, add. Multiply by 2, add. Multiply by 2. Okay, so we got it. Now let's look at the quotient. Quotient's this guy, right? From that. Clearly that's this. So clearly the answer, the roots are 2, negative 8, and 3. Again, my takeaway is always understanding is more important than memorizing. So devote the extra time now in your career to understand as much of math and physics as you can, and try not to accept facts given to you by your teacher on faith without convincing yourself that they're true if you have the time to do that. Bye.